All right. Let's. Well, I'm going to go through some stuff slowly with you up on Blackboard. I need to teach everybody how to use Blackboard. So let's take a few minutes and learn Blackboard mechanics. For those of you who already know how to use Blackboard, sorry, you just get to sit here and watch. So let's go ahead and go over Blackboard and make sure everybody understands how to properly submit an assignment. First off, I can't show this to you because my account got blown up. Let's see, how am I going to do that? What's that? Yeah, I guess I could do that, couldn't I? Okay, do one of you mind coming up here and logging on as your Blackboard account? Yeah, come here. Log on as your account so I can demonstrate them. So go ahead and log on. All right. So I'm in Blackboard, right? So I'm not in Blackboard, I'm outside MSJC. But let's go to Blackboard. And I want to go through a couple things. I'm going to click on Unit 1. I believe this is our class. All right. So let's go over, I'm going to go over a couple of things. First off, I want to go over I'm going to do how to complete the Chapter 3 activities. You see this assignment? It's called Chapter 3 activities. Everybody see that? So I'm going to right-click on one of these. So I'm going to do the first one. So I'm going to right-click on this. I'm going to save target as. And I'm going to save this packet tracer file. Now what I'm going to do is I'm going to save this to my desktop. Now if you log into this classroom, so if you're logged on as your account in this classroom, and you save this to My Documents, it will automatically go up to an apps.msjc.edu. Notice you have a My Documents folder. Do you see that? If you click on that, that My Documents folder will be, you're going to have to come and log on again. Hold on a minute, just when it pops up here. Once it's going to add, okay, I knew it. So come up, you can go ahead and log on. Sorry about that. We're trying to integrate Blackboard with so that your Blackboard account will work for apps.msjc, and so it's causing a bunch of hassle with the faculty account. So mine's not working again today. All right, so I just connected to see My Documents up here? That My Documents would be the same My Documents if you logged on here. So if you download all your packet tracer files like you just did and drop them in here, they're here. See that? So that's kind of nice. Well, if you're at home and you can't do that, then what you can do is you can take this packet tracer activity, see that? And I can right-click on it and choose Copy. And then I can go to the My Documents folder and I can right-click and choose Paste. You see that? Now you can't drag and drop. Notice that drag and drop no working. Right? No. But you can right-click and choose Copy, right-click and choose Paste. Do you follow that? So now I've got the file up there in My Documents. Now, important point is here, when any Blackboard, any apps.msjc software that I run in here will be able to see those files in the My Documents folder. So, for example, if I run Packet Tracer, so I'm going to find Packet Tracer in here eventually. Is it called, where is it at? There it is. All right. So I'm going to connect the Cisco Packet Tracer. That's going to launch the program. Okay, now if I go to open, it's going to give you an error because it's looking for a default directory. Don't worry about that. But it's going to open up and guess it's going to see the My Documents folder. Now the My Documents is the My Documents on the server, not on your local computer. That's why I have to copy the files into here. Now I've got that, I can click on this Packet Tracer file and I can open it. Every Packet Tracer file is going to have instructions for you. Some are going to be really easy, like this one. You basically read the instructions, right, and perform the steps. Now, let me show you a couple little things. Every one of these tell you what completion percentage you're at, down in the bottom right-hand corner of the instructions. You see that where it says 100%? So this is 100% completed already. That one was really hard, right? That was a pretty easy one. But you can also click Check Results, and it'll tell you if you finished it correctly. I don't know, can you see the screen? It's probably a little hard to see. You can also click on Assessment Items. It'll tell you what individual areas are correct or not right, and so you can get some granular what's broken. Now this isn't a very good one because there's only one thing to do. Open it, basically. But the other ones have more complex steps in them. Now, once you're all done with this, and you've got 100% complete, or as close as you can get, then you can go and click the Save button. So I'm now saving that file. Now I can go ahead and close Packet Tracer. So I'm going to exit out. Okay. Now the Packet Tracer file sitting here has my changes, my progress saved to it. Do you follow? Now, in the apps.msjc, now this is the important point a couple of you are getting thrown off on. So in the apps.msjc.edu interface, I can now go to Internet Explorer or Firefox. So I'm going to open up Firefox on apps.msjc.edu. So I'm actually running Firefox from the server. So this Firefox is not the Firefox on my local computer. This is Firefox in the server. So guess what it can see? The My Documents directory, just like Packet Tracer. So now if I go to my.msjc.edu and I log on as me, and I'm going to go to our class here. Go to Unit 1. Now, here's a couple of points I want to point out here on this. I'm going to go down to here. Now, it was you that asked me. So this is how you submit these things. So under Chapter 3 Activities, I'm going to click on that. It's going to open up a place to submit my assignments. This is where you submit your assignments. So I'm going to click Browse My Computer, and I'm going to click on that Packet Tracer file that I saved my changes to. You follow? I'm going to choose Open. Now, have I submitted all of them yet? No, I've got 3 to do. So I'm going to choose Save as Draft. That will save it, and I can come on I can click OK, and now I've got my draft. Now I can go back into it and upload the remaining 2 assignments. Do you follow me? Now once I'm all done with the remaining 2 assignments, then when I go to this activity file, I can post my other 2 files in here, and then I can click submit. When you submit, it closes the submittal down, and the only way to get it reset is to ask me, and I will clear it out for you. You will lose whatever you submitted. You have to resubmit it all. Everybody makes sense out of this? Any questions about that? Yes.
The PDF file, so the images and things.
Well, let's deal with that here in a second, separately. That's actually really easy. So most of you are trying to go through these elaborate schemes of trying to put content into the PDF file. If you want to do that, all power to you. You actually can do it. So for example, I'll go to this Chapter 3 activity. So I'm going to right-click and save as, right? Save link as. And I'm going to save this to my desktop just like I did before. Now, if you can also, it saved it to my server desktop, not my workstation desktop. But so now that I've got apps.msjc running, what you can do is you could actually open Adobe Acrobat Pro, and you could open that PDF, and it has a way that you can input text on it if you wanted to get tricky. So let me show you how to do that. You can open up the file, right, in your PDF, and this will allow you to overlay text in the areas that it requires. You got to go to, give me a minute here. It's one of these menus here. I don't remember how to do it. I know there's a way to, oh, here it is. So you can actually, this allows you to type in here. So for those of you who really want to actually type your answers on the PDF, then you can actually open the PDF with Acrobat on the apps.msjc.edu, and then you can use this under Tools, Content. You can edit the document text, and you can type your answers in the allocated space. And then when you're done, you can create PDF. You actually have to create a separate PDF. It's not going to let you edit the original PDF. You've got to create a second PDF with that content in it, and then you can upload that if you want to. I also would accept for you just to simply open up a Word document or a notepad and just answer the questions in the notepad, right? Put answers here. Save that and upload it. So either way, it's good for you. I don't care. But if you want to, if this is easier for you, it'd be a good skill to learn anyway. You know how to use Acrobat to edit the PDF file. And you can do that as well. All right, any questions about that?
I have one question about message tracer. Can you open it? It shows the instructions.
It depends on the file that you open. So you went to Packet Tracer, you opened it up. And is it completely blank? No, you got to open Packet Tracer. Then you got to go. You got to open the file. You got to click on the file and open it. You have to do it that way. By the way, if you did close that, it never actually closes. So you want to click the X. It doesn't actually close. It's still there. See? It looks like it goes away, but it really just minimizes. Apps.msjc won't open packet tracer? Is it giving you some kind of warning down at the bottom or a yellow bar? Do you see a yellow bar anywhere? Are you in Firefox or are you logged on as you right now? Go to Start, click on the packet tracer within your Start menu. Yes. You can download it from that Cisco Networking Academy, and you can install it, and you can use it local on your machine if you want to. Yeah, it's fine. If that's the way you want to proceed, I'm okay with that. All right. Did it work? All right, so go back to, now, everybody look up here. I want to show you one more thing. So focus with me because I got like 30 questions today, I think from each and every one of you. How do I submit? So let's just make sure we got it right. So the next thing is remote desktop. You see this icon, remote desktop? This is another way you can go about doing this if the process I just showed you is too difficult. So you can click on remote desktop. Dang it. We may not have permission to launch this, so let's find out. Oh, crap. It's okay. So you can run that remote desktop, and this provides you with a desktop. And it looks just like a normal computer would. You're basically running a computer virtually that's here at this environment. So notice that the PDF that I downloaded on my desktop, guess what? It's sitting right here, right? The packet trace that I worked on is sitting right here. Notice that my documents has my homework in it, or your homework, right? And I have access to all of the programs, such as Cisco Packet Tracer. So I can run Cisco Packet Tracer right from within this environment, right? So if you have a little bit, it's a little easier for you to get mentally around the notion of working in a desktop, then this might be more suitable to you. Well, we removed all the graphics so that it doesn't, for people that are working in coffee shops and stuff, it doesn't impact their connection. Because some people were complaining that when they're remote or using a wireless modem or using one of those Verizon MiFi type things, that they were struggling. So we've done everything we can to clean the desktop up so it doesn't require any bandwidth. So one of the things we did in that effort is to remove the desktop background. Well, you'd be surprised on what the desktop background does to your bandwidth, right? Especially if it's one of those active desktops that changes, and it's a real problem. All right, so that's using the remote desktop. When you log onto this remote desktop, it's as if you were in this classroom. So it's the same software on these machines, but in the desktop. Okay? Any questions? So I would recommend using Internet Explorer in here, connecting to Blackboard, and uploading all of your assignments through this, because then you've got the packet tracer file saved and all your work stays here, and when you come in the classroom and you log on as you, your work is there, so you can stay continuous in your work effort. All right, any questions? So further about that right now. Okay, let's go over a couple other items in here. So, we covered how to answer the PDF files, and these are really silly exercises. I just threw them in there to get your feet wet, right? This is just basic stuff. I just want to get you in the flow of things. I mean, some of these exercises were really stupid. I get it, right? But they're going to get harder here pretty quickly, and I want to get you in the mindset of how to do this, right? That's the goal here, not to challenge your skills. Now, I kind of okay. So then you got PDFs that you know how to deal with. You've got packet tracer files you now know how to deal with. There's one more type of exercise that you'll be asked to do, and that's the case study. So click on the case study, and this one requires you to do a little bit of thought about some of the stuff we've talked about. And I've blanked out the answers, although if you're really creative, you'll figure out how you can see those answers, but I'll let you figure that out. But you can read these and then answer the questions. Some of them will ask you to do a little bit of, you got to do an exercise at home or something, and to get to answer it, okay? So the case studies are going to start out really basic, like this one is real simple. It'll take you like a minute to do. And then every time we approach the case, they'll get harder and harder and harder. And the last one is pretty hard. Okay, so that's the case studies. You can start working on those. They're pretty self-explanatory. Okay, any questions about the submittals on here? Got the packet tracer file, got the PDFs, know how to handle that now, and you know how to handle the case studies. So those are your 3 major assignments. There's a couple other areas you got to know too. All right, now everybody look up here. I also want to walk you through how to deal with CCC Confer. So I'm going to go through this very, very slowly so everybody can do it. Now this isn't where you sit there and stare at me. This is where you write it down, right? So www.cccc, 4 C's, unfer.org. So CC, it stands for California Community College Chancellor's Office or some confer.org, right? I think it's California Community College confer.org. All right, so you're going to go there to the confer.org. Now, most of the classes I will be recording for your benefit. So I want to give you every opportunity to catch up or go back over stuff. In addition, we're going to have a really gnarly final at the end of this class, and I want you to be able to review material if needed, get caught back up on some of the stuff we talked about. So we've started out kind of light here, but starting tonight it's going to get a little tougher. So you might want to go back and look at some of these things that we talked about, especially starting tonight. So all you need to know how to do, see my screen up here. I know it's kind of hard to see. It's kind of, I need to get the lights off probably. But notice that there are 4 buttons here: Meet and Confer, Office Hours, Teach and Confer, Webinars. Under Teach and Confer, you're going to click View Archives. And here's where you're going to see all the archives of recorded classes. Now, I led you astray a little bit last class. I said, go find the one I did on Packet Tracer to learn how to do Packet Tracer. And it worked. That's a good tutorial. The problem was I was teaching the students in that class to submit me a screenshot. So that led some of you a little bit off kilter. I apologize about that. You don't need to be submitting a screenshot. All I want you to do is save the Packet Tracer file, and you'll be submitting that. Don't worry about screenshots. But up here you'll type Reams, and you'll click Find Archives. And here you will see a list of all the classes that I've recorded. Now, here you will see, so when was our last class session? The 29th? So here's 8/29, 7 o'clock p.m., Guy Reams Network Fundamentals. So I'm going to click Archive. Do you see where the archive link is? I'm going to click on that, and it's going to open up. In fact, what's nice about it is it opens up every class I've recorded for this class. It shows them in a list chronologically. But you're going to click on the 8/29 one. Actually, I'm sorry. I think there's 3. Yeah, you want the 829 one. And there's actually in 2 parts because I stopped and started the recording twice on accident. So sometimes that jacks it up. But over here to the right, you're going to click on play. Then you're going to have to open the Java tool. Now, some of you have the wrong version of Java on your machines. So you need to go to java.com and download Java 7. Blackboard Collaborate will only work with Java 7. So some of you have Java 6 or Java 5 and no worky. You have to have Java 7. So go to java.com and download Java.
Okay, everything launches.
All right, so here's me talking, and you can listen to that recording. Now, recently I've learned a problem that I've been having during these. It actually isn't showing the video in the recording. Let me see if I can figure out why not. Yeah, I wanted to show the desktop. I don't know. Did any of you actually play this? Are you seeing my desktop in the recording? Okay, the reason it's not showing the desktop here is because I'm running another session, so it won't let it rerun both. So that's what's going on. Do you see the video camera? Okay, so it's working. So I'm going to exit out of that. All right. So there you go. So now you have the CCC. That's how you get the CCC confer, and that's how you see the recording. Any questions about that? Yeah.
I try to do it instead of I have to create.
Yeah, I think I'm going to put a card sheet in.
Is it really asking you for an account, or is it just having you put your name in?
Well, I put my name and everything else in there. Just do it.
Yeah,
I don't believe you. Let me try it. So you're clicking on View Archives down here.
Yeah. Hey, right. Same thing. See how right there.
Let me log out. Let me log out first. Maybe because I was logged in, it would. No, I'll tell you what you're doing here. Hold on. Okay. So I'm going to click on Archive here. Yeah, it's not asking you to create an account. What's happening here is this software is being funded by a grant. So what they're probably trying to do is archive everybody who uses it, right, so that they can justify the grant. So they want to know who you were, what your email address is. This is not creating an account. They're just recording who you were. And then go and find your college. It doesn't matter. You can pick whatever you want. But Mount San Jacinto College, if you want to help them in their grant efforts. Unless we all want to really help Feather River College out. Make it look like they're really active. I don't know if they've ever even taught a class. I have no idea. Sounds like it's on a reservation, but that may not be. I don't know. Feather River College. That doesn't sound like a community college. I'm not sure who that is. It's probably a reservation or something like that. They have a lot of. They participate in the same efforts as the college structure does, but they don't. They share the curriculum basically. So you can pick one of these and then click Connect. Now you're not creating an account. You're just saying who you are. Did it work? Did you try it there? All right. Any questions about that? I want you to be able to view the archives if you so need to. So that I'm going through the trouble of recording it. It'd be nice if you could use it.
Okay.
All right. Good deal.
When I first connected, did like, oh, Internet Explorer,
Oh, I see. Okay. Next, you must have a Cisco Networking Academy account, and you must be registered in our class. This is separate than Blackboard. So I'm going to show you who has made it into the class right now, and you can look up there and see if your name's in it. If your name is not in there, you're doing bad. So here is the roster of people that are in this class right now. I know it's kind of, let me magnify it up. So that is who in the is in the class. If your name is not in there, then we need to work on it. So I have 18 or 19 of you in here right now, and I have 13 on this list. So 4 or 5 of you are not on this list. So who's not on this list? All right, so have you created your Cisco account? All right, so what I can do then...
And I remember leading to you and back saying I
don't know what the lady was doing. All right, so give me your username, the one you created on Cisco. What? Spell it. Like that? Who's next?
A-R.
E-A-R? P-A-R? Who else isn't on my list? You better figure it out. All right, let's...
R, more, and O-O-R-E, 135. I just logged in and just said you're not enrolled.
Oh, we'll find out. Who's next? Who is a Cisco account that is not enrolled, wasn't on that list? Anybody else? All right, so I'm going to click here and we'll see if you guys make it. All right, I was successfully added those 4 accounts into the system. So you can go check it now. Oh crap, I put you in the wrong class. I hate it when I do that, because I'm not paying attention. Oh, that's okay, I got it. It's all right. Don't worry about it. It's good. You won't notice a difference. I will. When I go to do grades, it'll screw me up. All right. I can also go and look through all the list of every student, and I can get your username if you need it. Takes a while. What's your first name? Carlo, like that?
Yeah.
It doesn't say you're in there.
Let me take 2 logins.
You did the TCO one at the top? You did the wrong one. So go back and find that email and do the right one. All right. Am I missing anybody else? So when you log on to the account, you will have an assessment area. No, don't worry about it. Yeah, there will be an assessment area. I don't know what it looks like. Mine looks different than yours. There are no active exams right now. Every week, Kay's activating them, except for this week, because she partied all weekend, I think. But see, basically, watch what happens. I'll go and I'll activate them all. You are? Okay, good. So I'm activating exams right now. It's something that we have to do. I can't activate them for longer than 6 days. So right now, all the exams are active now. So if you refresh your screen or whatever, then you'll see that you have Chapter 2, 3, whatever available now to take at your discretion.
And they're not retakable.
No, unless you beg me, like hardcore beg me, provide me money, something, right? It's painful to reset the test. It's not easy. So anyway, so my recommendation is to read the material really well, so you know it, and then go take the test, right? Novel concept. So anyway, there you go. Any questions about that? You must keep on top of these. Now, back to Blackboard. I've given you dates that are loose for when this stuff needs to be done so you keep on top of the class. I don't want anybody to be down here in Unit 4 and just realizing how overwhelmed behind you are. I'm trying to give you, but these are not going to disappear. They're active the whole class. So you can take it, do these at your discretion, but I've given you a guideline on when I think you need to have them done by. All right? So my goal is that you would be starting to wrap up Unit 1 sometime around now, because guess what's going to start happening here in about 10 minutes? We're going to be starting into Unit 2, right? So, right? And we're going to go through 6 of these. And every time we do one of these, there's going to be more and more assignments due. So it's going to get harder. I'm trying to get your feet wet slowly, kind of like a frog in boiling water. Because if I introduced Unit 5 to you right now, you'd all just quit, right? So I'm trying to get you gradually into it, right? So, you know, so this isn't a hard set due date. This is my recommendation to you, all right? So the next unit, I would recommend that you get done with this material for the next unit between now and the 19th, which is 2 weeks from now. Notice I've given more time to the harder units, right? So that's kind of the way I designed it. All right, any questions about that? I've also built in towards the end of the class a week or two for us to prepare for the final, because that takes some preparation. So my dates here are guidelines. That's really what I wanted to say. All right, any questions? Yeah. What does it do? All right, what browser are you in? Okay, so let me just, everybody know this, right? The only browser you can use is Internet Explorer. So did everybody hear that? Because you're not the only one that said that same thing. So Internet Explorer is the only browser that you can use. Unless you can do a cute little IE tab within Firefox, which you can do, right? It only will work with Internet Explorer, right? And the reason why is because it needs ActiveX. And Firefox doesn't support ActiveX yet. Now, once Firefox supports ActiveX, we'll be in business. Because all it's doing is calling up the remote desktop client on your machine. That's all it does. But until Firefox supports that, we won't do it. And until Apple decides to support ActiveX on their operating system, it's not going to work on a Mac unless you do some trick. Right? So the login will work. All that works with Firefox. So it's deceiving. But when it goes to try to actually show you the applications, the ActiveX component can't load. That's what's happening. All right, any other questions? I just want to make sure everybody's on the same page. Now, if you blow an assignment where you screw it up and you need to reset it, then kindly send me an email, preferably with your name in the email, because sometimes you send me to an email from wickedtwinsister@hotmail.com, and you say, can you please reset my Chapter 1 exam? Like, what the, who are you? That would be good. And also, it would be a little bit helpful because I'm teaching 2 classes if you told me what section you're in. Although that's not a requirement, I can figure it out. It's just annoying. I mean, I'll figure it out. As long as I have your name, that's what I really need. And now sometimes your name is in your email because you sent it to me from your college email, but a lot of you don't use the college email. So you use, you know, the Hotmail account, right? So anyway, you get the idea, right? Okay, we're ready to dive into Unit 2. So let's go ahead and open up to Unit 2. And I'm going to be a little bit more diligent about explaining a few things here because they're going to get a little bit more difficult now. The assignments you had before were just brain dead assignments that were kind of easy. It's really a matter of the mechanics that was a big question, not necessarily the ability for you to understand how to do a Google Earth thing or whatever. Now we're starting to get into some actual technical subject matter. So we want to spend some time with this. Okay. First off, there is a case study. So let's go ahead and take a look at the case study. I want to make sure you understand what it is you're up against. So the Chapter 4 case study basically is going to have you analyze and talk a little bit about the transport layer, and they're going to ask some questions here. They're going to make you kind of think a little bit about the role the transport layer plays in troubleshooting. So it's giving you some what is called an output, a dump of what a TCP dump would look like, and it's going to ask you some questions about that. Now this is going to seem really crazy to you. You've never seen this stuff before. So you're going to read this and you're going to say, what portion of the output, which TCP flags identify the three-way handshake? Now, it's going to, I know what your mindset's going to be, oh, that's crazy. I don't even know. Forget it. I'm not going to even look at this. But you really need to sit there and stop for a minute and ask yourself, what does this mean? Because buried in this little communication right here is information in the TCP or transport layer protocol stack. And it's critical to understand this protocol. So that's why the question. Now I'm going to be going over the transport layer in heavy detail starting tonight and next week. But start on these exercises now. The reason the case study is there is because when I start talking about this tonight and I start talking about it next week, and I start talking about the three-way handshake, you'll be right there with me, right? Because you've been having to engage in it by thinking about it in this case study. That's why I put this here. That's why I want it here, is to get your minds where I want it to be to have this discussion. Okay? Now, next one, so that's the case study. Answer those in Acrobat or in a notepad file. That's fine. So let's go ahead and take a look at the next exercise. Okay. Because the activities are much more involved now, I've broken them up into their own individual activities that you complete. Rather than doing them all at once and submitting them, because those are kind of silly exercises. Here is where you're getting into some more difficult ones. So I just want to cover these a little bit with you just for a minute. So some of these are going to be a little bit difficult, meaning they're going to have you take a look at a process and do some analysis. Next week I'll probably go through one of these with you just to kind of give you some idea on it. But start digging into these. You'll learn a lot just by doing it. Some of them are helpful that way. So for example, I'll do this last one. I'm going to just mess your desktop up, man. Your pristine environment's going to be ruined. So I'm going to open that file up in Packet Tracer here. So I'm opening up the Analyze Application and Transport Layers exercise. And notice that you get this file right here. See that? Now, look in the bottom right. What percentage completion am I? 0%, right? So every one of these is going to have what is its policy. Now, yes, don't ignore this. Your tendency is to look at a block of numbers and just glaze over and go, oh, I'll never understand that. But don't do that. Instead, try to dig into this to kind of start getting what they're talking about. Because what's going to happen here is this is going to get built on. Every exercise we're going to do from now on is going to build on this, and it's going to get more and more complex. So if you understand this topology now, come the next unit exercises, it'll build on this, it'll build on it, and build on it. Now, why am I making a big deal out of this? Well, when we take the final, I'm going to give you a packet tracer. This can be based on this scenario that you've been building on every activity you've done. And so if you've been keeping on top of it, the activity will be relatively easy because you're like, oh, I already know because I've been doing the activities, right? So make sure you stick with this because when you come to do the final, it'll all gel together, right? The final is like a culminating activity. So that's good. So what you do now is you're going to read through this, and you're going to do things. So it says this is right now. First off, the server's been replaced. You need to configure the server with an IP address. So it wants me to give the server 192.168.254.254. So I'm going to go to the server. I'm going to open it up. And by the way, Packet Tracer. It's kind of cheesy, but it's good because you actually have to turn it on. You have to power it on, like with a power button, just like you would a normal computer. But I can go to, so you notice when I click on it, it says device must be powered on. Oh, okay, all right. So you got to find the power button. Where is the power button? What? To the right. Ah, power button, right here? Oh, it's on. Yay. The computer's on. So now I can go to desktop, right? And now I can do some configuration. So here's what I want to be is IP configuration. And what IP did it want me to give? We got to go back to the instructions and look. 192.168.254.254. And then it wants a gateway of 254.253. Right? So I'm just simply I'm getting that now. It wanted a DNS server, right? Yeah, there you go. Okay? So, you know, you get the idea. I'm following these instructions. I'm implementing the rules. Now, notice what happened as I completed that IP configuration. What did my percentage go up to? Notice that my percentage is now 26%. So I've completed a portion of the exercise. Now, if you click on check results down here in the bottom, and I click on assessment items, you'll notice that, aha, I've got the default gateway done, I've got the IP address done, I've got the subnet mask done, and I've powered it on. Woohoo! So as you complete it, you can see, okay, what have I missed? I missed this, I missed this. You can go back through and you can figure out what you need to do. So, okay, I need a DNS server. I don't know if it actually told me the DNS server, did it? So I'm going to close that now. It wants to enable it, so I got to go to config, and I got to go to DNS, and I got to turn it on. That's what it wants. I got to turn it on. Right here, on. And then it wants some information there too. And to get to, oh, now I'm up to 33% because I got the DNS server on. So you just got to keep going through this and figure it out. So, oh, and it wants eagleserver.example.com. Okay, so it wants my IP address in there with 254, 254. So I got to go up here and put in this address. Actually, I'm sorry. I got to put the address in here with 192.168.254.254. So that adds the DNS server into this thing. And now I'm at 40%. You see, as I complete each one of these items, it's going to increment my percentage completion. Do you follow me? So now it wants HTTP enabled. So I got to go to HTTP, turn that on. Now I'm at 46%. So forth and so on. Now another thing it's going to want is it wants me to connect the Eagle server's FA00 port with the router 1 ISP router. So now what I'm going to do is I'm going to close this guy, and over here I'm going to click on connections down here, and I'm going to find a copper crossover cable probably, and go from fast Ethernet to router. And I've connected the server to the router. And notice I have little green dots. That means I'm connected, right? And so every time I do this, notice I'm up to 60% now. Okay? Now some of these are going to be various levels of difficulty. and they're going to get a little bit harder. But we're going to spend some time with these over the next couple of days. We're going to be building some packet traces together and doing some activities here on the machines. But I want you to understand kind of how to stumble through these. Any questions about packet tracer up to this point? All right, there you go. So at any time you can save your progress and you can exit. Now I have a file sitting here that has that progress saved. So if I were to open this file up again, you'll notice that I have 60% complete. See that? Because I saved my progress. You don't have to finish this all in one sitting. You can come back to it. All right, there you go. So you have a packet tracer activity for every major discussion in your curriculum that you're going to be reading, and they're all here. So you're going to click on these, and after you're done with the completed packet tracer, you'll browse and upload the completed file. Okay. Anybody have any questions? So I'm going to move on to something else. All right. So we're done talking about that. So I'm ready to move on with the transport layer. Okay, so we're going to talk about the OSI transport layer. We have up here, I've got this PDF file that is uploaded. You can look at that as well. I'm going to use this as a discussion point to start us out. And then as we progress here, we'll dive in more deeper onto the transport layer. First off, let's cover once again what the basic responsibilities of the transport layer are. Can anybody remember any of them? Name one. Anybody got one? Do you remember from our previous discussion, I think it was a week ago? What is something the transport layer is responsible for doing? So at the transport layer, when transport layer has many protocols that work at the transport layer. A sample protocol would be TCP or UDP. Those are the two major protocols that work at the transport layer. There are other protocols that work at the transport layer besides TCP and UDP. And a lot of them are being used today. For example, SPX, back in the Novell NetWare days, was used. Or a protocol called NetBUI had transportability. AppleTalk, you might have heard about. And there are others, but these are really not used anymore. What we're really talking about now is TCP or UDP. Now, when we use TCP, we talk about a concept called segmentation. So segmentation is the concept of taking a bundle and breaking it up into little parts, right? Why would we need to do that on a network? Well, I could transport them all at once, right? I could just take a giant stream of data and shoot it over to you. Well, yeah, on an Ethernet network, Ethernet networks are a contention-based network. Well, unless you're on a switch. But traditionally, they were contention-based, meaning on a copper media, only one machine could talk at a time. So because of that, if I'm hogging up a whole wire during my transmission, nobody can talk. That's bad. So a lot of networks break things up into smaller segments or smaller chunks so that we can carry on multiple conversations at once. See, the idea with digital versus baseband communication, or digital baseband communications versus broadband, if you have a range of frequencies that are available on a given media, right? And you're using that, all of the frequencies of transmit media on. And baseband or digital communications, you use the entire spectrum. So let's say this was 1,000 megahertz of frequencies available, right? Then you would use all the frequencies to make this communication occur, right? This is called baseband. Let me detail that out a little bit more specific. Let me just give you a little rundown, and then we'll get back into why we need the segment. Sometimes people have a hard time conceptualizing this because they don't get it. So let's just really quickly run down what actually happens. So think about it. On the back of these computers, you have a network interface card, and plugged into that network interface card is a little copper cable. It's actually 8 little copper cables plugged into the back of your machine, and that goes out and eventually connects to another machine, right? So I have a question for you. How does this network card transmit data onto this copper media over to this other network card? How does that actually happen?
It goes down the layers.
What's that?
It goes down the layers.
Well, yeah, it's going to take data and put it through all layers of the OSI model, as we talked about last week, until it becomes what?
Binary.
It's going to become binary digits, right? Now, we know that text can be converted to binary. So eventually it's going to become ones and zeros. So we have a bunch of ones and zeros. Whatever. Actually, let's get a little bit more specific. Let's take a look at, I'm going to go to Google here real quick. So we'll do ASCII character map. So here we go. So where's the letter D? Right here's the letter D. So the letter D, the decimal equivalent of the letter D is 68. So if I were to open up my calculator, the number that we assign the letter D, I'm going to go to my programmer mode here. What did I say it was? 68. And I'm going to convert that to binary. So there's my letter A, right? Or D, sorry. Damn. 130, all right? So I'm going to send the letter D out on there. So what is it? 1000, what? 100. 100. All right, so we now all agree that I can eventually convert text to binary. Because I have these little handy-dandy ASCII conversion tables, or whatever I was using, right? But so I have my binary, it's ready to go out. Now, every time I send it to the layer, it's getting more and more stuff added to it. So this one letter D is going to require TCP payload, IP payload, right? It's going to require a MAC address, downlink layer payload. So an 8-bit character letter, an 8-bit letter A is going to take two 48-bit MAC addresses, source and destination, two 64-bit IP addresses, IP and subnet mask, source and destination, plus all the other stuff. So to send one letter can take a lot more than just a letter, right? So I got to send the letter out now that we've got to be all agreed that the letter D is going to take 1 million little bits to send, then how does it actually make it onto that media? How does it happen? What?
That's about it outside the frequency.
Yeah, you were in there. Did we talk about that in this class?
Yeah.
Yeah, we did, didn't we? I missed some classes. Okay, so if we go back to the conversation we had, we talked about it. We had this wire, and I'm so glad you all remembered. Just remembered the answer. I like that. So we have this media cable sending electrical circuits, right? And how is it going to do that? Remember our last conversation. How is it going to happen? What? It's going to send voltage. And it's going to send voltage across every frequency, right? So it's going to use the entire frequency of that cable. So it's 1,000 megahertz, it's going to use the entire frequency. So why do we segment? Right? If we're going to be using the entire frequency and the communication being only one way, so this is going to be this big stream coming out. What if this guy wanted to talk? Hey, I'd like to talk now and then. What has to happen for this guy to talk? This guy has to shut up for a little while, right? So if we want to carry on what is considered to be apparently simultaneous transmission. See, baseband isn't really simultaneous communication. But if we want to carry on what we perceive as simultaneous, then we need to have interruptions, right? There needs to be brief pauses in the communication. So this is what we call segmentation. Or this is why we segment. All right. However, in the UDP world, we oftentimes call the process not segmentation, but we call them fragments. This can get confusing because the IP protocol or the network layer protocol is capable of fragmentation. So that can become confusing to us, right? But that's just the way it rolls, right? So the UDP protocol is typically called fragments. Now there's a reason. Now, so one responsibility that we talked about for the transport layer is segmentation. Another one is error recovery, right? Another one is sequencing. Reliable delivery. And flow control. So all of these are things that the transport layer wants to take care of. And the reason why it wants to take care of those is because we would like the communication to get to the other side. So TCP has a mechanism for handling all of those functions. It can handle segmentation, error recovery, sequence, reliable delivery, flow control. UDP, on the other hand, doesn't care about any of them. The only thing UDP cares about is segmentation. So that's why UDP calls them fragments. It just sounds better, right? Fragments sound not as important. They're just fragments. Segments sound like they got to be put back together, right? It's just it's a terminology. So TCP is considered reliable, connection-oriented communications. Why is it reliable? Can you tell why? Because it has error recovery, right? And it's connection-oriented. Connection-oriented means it establishes a connection with the other party before it transmits. UDP is called unreliable, connection-less. right? So, man, I hope my wife never listens to these lectures sometimes, because I like to use examples from my home life to depict protocols. So, if I went home and I come in the door, and I open the door and I walk into my house, and my wife immediately starts in to some issue or problem she's having with me or the kids, that would be connection-less, right? Just a flurry of stuff. Now, how much of that am I actually going to pick up? Not a whole lot, right? I'm going to get fragments of the communication, right? Now, if I came in to the door and my wife greeted me and said, "Hi, Guy." Well, hello, wife. "How are you doing today?" "I'm doing fine. Why do you ask?" Right? Now she has established what? A connection. Right? She's negotiated the parameters for the beginning of the conversation. Right? So now she's going to start throwing stuff at me. And now I'm going to be picking up segments of her communication, right? And I'm going to be able to reliably or somewhat reliably put them back together. Does this make sense? This is the difference between TCP and UDP. TCP was connection-oriented, and UDP was connection-less. So, what do you think your, I don't know, what chat programs people use nowadays on the internet? Skype. Is there something else? What do they use on an Apple? Skype? No, there's something else. Apple Talk, whatever. So you're Skyping with your buddies. What do you think Skype uses? I don't know. It's kind of an interesting thought. Yep. You know, I don't know, actually. Yeah, because I think what happens with Skype is, yeah, I would like to make sure that my characters get there when I talk, right? But I don't want to have to wait a whole long time for connection delivery to happen, because I don't want there to be a stutter in my communication, and I don't want there to be a stutter in my typing, right? So maybe not. I don't know. It's an interesting thought, right? So the issue is, whenever you want something to reliably get there and you have time to wait a little bit, then TCP is your protocol. If you need something to get there right now, quick, and reliability is a secondary thought, then UDP is your protocol. Does that make sense? So a log-on attempt, when a computer attempts to log on, a lot of times that's UDP. Because if it doesn't get there, what can the user just do again? They can just try again, right? Not a big deal. Okay? All right, so that's TCP and UDP. You get the idea. So not every protocol that works at the transport layer is going to work at every layer. It is not going to handle every one of these functions. I mean, so, but those are the core functions, which you see on the board right there: segmentation, error recovery, sequencing, reliable delivery, and flow control. Those are the core functions of the transport layer, and that's what we're going to be hitting on here. All right, so let's do that. Okay. Transport layer. Now, looking at this slide here, hopefully you're beginning to understand this idea of layered communications in the computer or in the software. The transport layer's responsibility is to take application layer data, bundles of application layer data, and handle the transportation of those virtually to the transport layer on the other side, right? So the transport layer on the other machine has no clue that we're passing through all this crap to get to it, right? So that is what it is responsible for. The transport layer then passes this data down to the network layer, or receives the data back to the network layer. So that's pretty much what the transport layer needs to do. This picture shows you that virtualization process. The application believes that it's talking to the transport layer, and the transport layer creates a virtual connection to the other transport layer, right? It's this virtualized connection between transport layers. So the transport layer feels like it's talking directly over to the other transport layer, even though it's going through all this other stuff down below. It creates this virtualization. How does it do that? Do you remember? How does the transport layer accomplish the virtualization process? What mechanism does it use? I showed you Internet Explorer. No, I used Internet Explorer. I had you open up a telnet prompt, and we connected to something called a, starts with a P, a port. So transport layer creates a socket, which is the IP address and the port number combined. So it creates a connection to an area in memory on your machine. So your application layer protocols dump data to an area of memory that can be picked up and or delivered by the transport layer. So transport layer creates this virtualization with port numbers. So any protocol that uses TCP/IP communication does this. I have a 9-year-old at home, and all of his friends got into this game called Minecraft, which is really interesting to me because we can completely dumb down games now so much. But what makes them cool is that they're dumbed down now, right? When I was a kid, you had to lay up the game, like, you know, like StarCraft. You had to take it up a notch, but not anymore, right? We don't need that anymore. We're going to put blocks around, and kids are enthralled for hours. But the thing is he wanted to run his own Minecraft server. So he got the Minecraft server running on the machine, and he came to me with this perplexing issue. Dad, yeah, I got Minecraft server running on my computer. Good for you. I can connect to it from the other computer downstairs, so I'm able to run, I can connect to Minecraft from downstairs, but my friend across the street at home can't connect to my Minecraft server. So what's going on, Dad? Right? So what he didn't realize, he was asking a very interesting question, right? So I pose the same question to you. Why was his buddy next door not able to connect to the Minecraft server? Well, it has an IP. He's able to connect to it local. So what was that? Well, he's not connected to the local area network, but why is that a problem? It's interesting. It's an interesting concept, right? So let's just talk about it real quick, because I think you need to understand it. So let's pretend like we're going to set up a Minecraft server. Because we all want to set up Minecraft servers, right? I know you all are itching to go home and set up a Minecraft server. So we're going to run the Minecraft executable on a server, right? And that server is going to have an IP address. Right? So this is the IP address. Now what does the IP address accomplish for us? What layer does that work at? It works at the network layer. You would have failed that test question. That is one of my final test questions. What layer does the IP protocol work at? So just write that one down so you'll never miss it again. All right, so the IP protocol works at layer 3, right? So if I have a Minecraft client here, and the Minecraft client has an IP, they would be able to talk at layer 3, right? Now we have layer 4 to deal with, which is the transport layer. Now the transport layer creates the virtual connection between the two machines, right? So this executable is going to be dumping its data to an area of memory on this machine. The transport layer, TCP, is going to create the link between here and the Minecraft software running over here. So TCP is going to create the link between the area memory here and the area memory here. And it's going to do that by port number. So this is going to get a port number assigned. I think it's like 23565 if memory serves right. So this is going to be a port number. That's going to be the Minecraft port number. TCP is going to map that port number to this area of memory. Whenever the Minecraft client, who can already talk IP, needs to grab data from the Minecraft server or put data to the Minecraft server, it's going to send its communication to port 23565. Does this make sense? A session is going to be established. So this guy knows what port's over here. Let's call it port 10,240, 200. So this guy, they now know each other's ports, and they're going to send data back and forth to each other. And if you know anything about this Minecraft, which I learned because my son brought it to my attention, I never heard of Minecraft before until 2 days ago. He came to me and said, all right. And so I ran this. So after I realized this little teeny application was devastating his little computer because it runs OpenGL graphics, I realized the amount of network activity going back in here was pretty intense. I guess it uses the Quake engine. But anyway, it's sending a flow of activity back and forth between here, right? Now, here's his friend over here. His friend has an IP address. Now, is his IP going to be able to connect to this IP? So layer 3 is not going to be able to talk. So step 1 is we have to get layer 3 to talk. So see, he has his parents have a router, a Verizon router here. And the Verizon router converts their public IP address through a process called NAT to their private IP address. So it flips this IP to this IP. So whenever this guy goes out to talk, he's actually coming out with this IP, right? At my house, I have a firewall, and my firewall is also going to NAT internal IPs to an external IP, right? Now these two IPs can talk because they're on the global internet. Now if I went in here and I could create a rule in my firewall that allowed this guy to NAT over to this IP, so whenever somebody came traffic into here, create a virtual IP, we'll call it a VIP, virtual IP. If I created a virtual IP that mapped this IP to this IP, then this guy could talk to that IP, right? Because I'd be natting from this box. So let's say I accomplished that. Am I done? Is Minecraft going to work? No, it's not. Because I've accomplished layer 3, but what I missed, this is where my son broke down. He accomplished layer 3, but he didn't get higher up the stack, right? He needed to get to layer 4. What had to happen is I had to allow for 23565 in the firewall. I had to allow that port to go and talk to this port. So when this guy tries to communicate with port 23565 on this virtual IP, it redirects that port to 192.168.200.22's port 23565. So that's what had to occur.
And you have to enable port forwarding for that to work, right?
Well, port forwarding is the term that maybe some routers use.
Okay.
So like a Linksys would use the term port forwarding. This particular product uses a different code. But yeah, you basically right. Port forwarding is usually for devices that don't use NAT. They use a thing called CAT. And you can only have one IP. You can't have multiple IPs. You can only have one. And instead of translating the layer 3 address, you're only translating the ports that come in on it. So that's what they call it. Anyway, bottom line is, the thing I'm trying to drive home at is TCP creates this virtual layer above all this stuff going on. Right? So my son had to get layer 3 connected, then the ports had to be able to communicate, and then you have the communication going on. And now I'm in trouble because all my network bandwidth is being sucked away by 9-year-old kids playing Minecraft. All right, so you got the idea. You understand that. So here are the protocol requirements. So transport, we want it to be reliable, to acknowledge data, all those things I've already told you, a little bit different words, but all the things I wanted to tell you. So that's the transport layers requirements. Now, the thing I want to point out on this slide is some communication needs to be reliable, like that email that we send, or the website we're getting to, or the Amazon.com stuff we're buying. So we want that to be reliable. We want it to be acknowledged. We want to know that it got there. Reliable communication. Some communications, like streaming video, like your Skype, or IP phone communication, needs to be really fast with low overhead, meaning there's not a lot of crap thrown in there and it goes fast. You can imagine why. Imagine does anybody have a voice over IP at home instead of you do? What product? MagicJack. So MagicJack or Vonage or one of these. So when you pick up that phone, you have a conversation with your buddy. Now you'd like that to be reliable, but when you pick up and have the phone, you don't have time for TCP to do error recovery. Could you imagine you say, hello, this is Guy, but instead it drops to this is, right? And then you have to wait for this is to get, so it comes, hello Guy, this is, right? That's not going to work, that's not going to happen in a real-time communication. So in that case, we need to strip away all this reliability crap, right? And error checking, resending, all this. And instead, we need to have fast, reliable. So therefore, this is why the TCP/IP protocol stack has TCP and UDP as 2 protocol requirements. In the networking world, we have 2 protocols we commonly use. One's called FTP, File Transfer Protocol. Do you think FTP is this or this? Is FTP TCP or UDP? No, it's TCP. Why? Do you use username and password when you use FTP? Yeah, FTP usually requires username and password unless it's anonymous. And what are you transferring? You're transferring files. When I get that file, I like to make sure the file actually made it, right, intact. All right, so FTP is reliable. Now we have another protocol called Trivial File Transfer Protocol. Trivial File Transfer Protocol doesn't require a password. In fact, if you're a TFTP server, I can just start dumping stuff on you. So if I find out you're running TFTP, I can just start, and get it or not, I don't care. Here it is. Take it or leave it. So TFTP is oftentimes used to back stuff up, like a configuration. So TCP is FTP, UDP is Trivial File Transfer Protocol. All right. Okay. Now you can see here, if we were to take an actual look at the TCP protocol and look at the amount of data in it on a binary level, right, you would see all this stuff in there. You would see a source port, destination port, right? It's port numbers, let's tell you. You would see a sequence number, an acknowledgement number, header link, checksum, various options. You would see all that overhead from 20 bytes of data would be up there. UDP would only have a source port, destination port, and a link. You're done. So you can tell that UDP has less overhead than TCP. Follow me? So the protocol is designed differently for that reason. All right. Blah, blah, blah. Okay, I want you to use a tool on your machines. So, how can I do this the best? All right. You can't have any web activity going on at all on your computer for this to work. So shut down all your chat sessions, your little video games, whatever little thing you do to keep yourself entertained, because you can't handle not having multiple stimuli happen at once. So make sure you shut down all internet activity that you can. And then I want you to go to Start Level here, and you're going to find a program called Wireshark. It looks like a little fin sticking out of the water. It's called Wireshark. So you got Wireshark open. It looks like this when it's fully maximized. It's probably not on your laptop unless you've downloaded and installed Wireshark. Okay, Wireshark is another hacker tool, kind of. It's called a protocol analyzer. It allows you to analyze a protocol and look at the contents of the communication stream. Sometimes in the business you'll hear it called an Ethernet sniffer. That's a little confusing, a little incorrect. The sniffer is the device that is the protocol, the system that's actually grabbing the packets off the wire. The analyzer is analyzing them. So in this case, Wireshark is the analyzer, and it's using a sniffer that you can't see behind the scenes. It's an open source sniffer that they've got installed. So a sniffer and an analyzer are really two different things. But for the most part, Wireshark is going to sniff and then analyze a protocol stream. Okay. So first off, I want you to do a couple of things. You're going to click Sample Captures. So click the Sample Captures, and you're going to see a variety of sample captures up here. Do you see that? And see the one where it says HTTP, Hypertext Transfer Protocol? I want you to click on that one, and you'll get this right here. Okay? So let's just go simple. See the one that says http.cap, a simple HTTP request and response? I want you to right-click on that, save target as, and save that to your desktop. Oh, no, you can't do that. I'm sorry. You actually got to click on it. And then you can click download. And then save it to your desktop. So I've completed that. Now when I go back to Wireshark and go File Open, I can go to my desktop and I can find the http.cap file. Maybe. There it is. So I've got my Wireshark capture file. Do you see that? I'm going to click Open. Now all of us should have the same file open. Now Wireshark has 3 panes. The top pane shows you all your frames. The bottom pane shows you the frame detail. And then the bottom is the raw binary and ASCII characters. Now, all of this should have the same stuff, so I can refer to the frame number and you can see what I'm saying. Now, I want you to click on frame 4. Now, the reason why this is relevant is we just went through this last class. You remember I had you go to Telnet and do the HTTP get / thing, and it's just Yahoo does a bunch of crap at us? Well, take a look at this. The HTTP protocol is layer 4 in this communication, right? You see that? No, that's layer 7. That's layers. The application presentation session layer. So break that upper layer protocol down, and what was the command that was ran? See, it says get. So it's going to get this file. So what it wants to do is get, remember I told you HTTP is really simple, right? Just get file. So it wants to get this file. And so that's what it's going to do, is get that file. And it's going to get it from this site. Okay? So that's an HTTP GET request. And now, in the bottom of your screen down here, do you see the very bottom? You can see that the text for that actually there. Do you see it? There's the actual GET commands. That's what it looks like going across the wire in ASCII. If you want to know what it looks like going across the wire in hexadecimal, it's right here. So that command, get, right here, looks like this. So there's the word get in hexadecimal. 47, 45, 54. Now if I were to go convert that to binary, I can see what the strings and ones and zeros look like, right? Everybody follow me on that? But one thing I want you to realize is you look at this, notice this is organized in layers. Here's my application layer protocol stack. Here's layer 4, here's layer 3, here's layer 2, right? You see it? Now, so you can imagine somebody sat down here and typed get download.html or http://eGrill.com/download.html. And that produced this packet form. However, I want you to notice there were 3 things that happened before that. You see that? Frame 4 was the first one that went out with that get command. But what happened before that? Notice you have 3 TCP communications that happened before that HTTP communication. Notice there's no application layer data happening here, right? There's no application layer data being communicated. This is only the transport layer communication. And notice there's 3 of them, right? 1, 2, and 3, right? Right here, 1, 2, and 3. This exchange is called the TCP freeway handshake. Basically, in layman's terms, it is this. The machine that would like to communicate sends out a response that says, hey, I would like to communicate. Here's my attempt at a synchronization number. Here's my flow control, my window size. And then the server responds back, oh, and here's my port number I want to start talking on. So the server sends back, oh, thank you. I recognize the port number you want to talk on. Here's my port number. Oh, I'm not very happy with your window size. I would really rather it be this. I'm acknowledging your synchronization number, and I'm giving you mine. And then the response from the machine comes back, says, okay, I'm cool with your window size, right? I acknowledge your synchronization number, and I acknowledge your port number. Is it okay if I start sending you stuff now? Or no, be on alert. My next bit coming out, my next synchronization is going to be data. And then guess what happens? So now the three-way handshake is happening, guess what's going to occur? The first data gets sent out. So three-way handshake, data gets sent out. Do you follow me on that? Now if you scroll down to the bottom, when the communication's all said and done, they don't even show you that. Never mind. One thing that also has to happen is the TCP session gets torn down, right? Broken down by a three-way process as well. All right. So take a look at, let's go back to number 4. And I want you to break out the TCP protocol. Notice that I have the source port, 3372, right? The destination port, which in this case is port 80, right? And I have a sequence number, an acknowledgement number, and I have a window size. There you go. We'll get into more of that, what that means later. But I want you to get the general idea of how TCP is formatted. Now, this doesn't have any of my data in it. This is all the information that has to be packed on this in order for me to send the data, right? And then, you know, you got your internet protocol. Your internet protocol, layer 3, has all the IP addresses. And then you have your layer 2 data, which is Ethernet. All right, any questions about that? Now, at any time, you can use Wireshark to capture real-time data going on your network right now and watch it, if you're curious. So if you're bored, you can go home, and you can go to Capture, Start. Oops. Go to Capture Interfaces, I'm sorry. Go to Capture Interfaces, and then see where the Intel interface is. Click Start. And now you're watching stuff leaving your computer. So if you really want to see how much crap you produce with one chat session or whatever, or one game, then run Wireshark and just see how prolific it really is. Like here, let me look at all the stuff flying across, right? So I'm going to go to, let's go to that Yahoo site. So here we go. I'm going to Yahoo. Look at all that. I don't really like this one right here. That one looks suspicious. It's got a bad checksum, which is not a good sign. That usually means it's a virus or a worm attempt. I think it is. So there's some software out there that's trying to hack into machines on this network, and it's hammering my machine right now, trying to, I don't know what it's trying to do. Yeah, see, the telltale sign is it's got a bad checksum. If I click on one of those bad ones, it says header checksum. You see it? It's bad checksum. That means that what was sent is not what was received. So look how much junk that's producing on the network. Well, you can scroll up and then it doesn't scroll so bad. See that? So now I can ask myself, where's that coming from? It's coming from the IP 74.200.25.230. And I can start researching where that's coming from. I'll have to look at that a little bit more carefully later. All right, so that's how you do you look at TCP. So all of this stuff right here you're seeing on the slide, you can see there in your Wireshark. All right, now let's talk about flow control. So TCP accomplishes flow control, but in order for it to do so, it must establish a handshake, the three-way handshake. And what you're seeing right here is the establishment of the connection between two machines. So if you look up here, you'll notice it's going to send a request. There's going to be an acknowledgement sent, and then an acknowledgement that comes back. If you actually open that Wireshark and look at that HTTP cap again, in order to do it, you got to stop your capture. So I'm going to open that HTTP thing again. If you look at that TCP three-way handshake, it's a little easier to see. So up here you'll notice that under the TCP section, it's attempting a synchronization. That's why we call this a SYN, S-Y-N. And notice it's trying to establish its port number and it's trying to establish its window size. The one that comes back, right, is also a SYN and an acknowledgement. Do you see the flag is set to acknowledgement? Now, go back up to number 1. Notice, what is the sequence number here? 0, right? Now, go to the second one. The sequence number is 0, but the acknowledgement number is 1. The way this works is two machines and a synchronization acknowledgement. This machine sets its synchronization or to 0, and this guy acknowledges it with the 1 back. You follow me? And this happens bi-directionally. So this guy's going to send a 1 acknowledgement back and a SYN to 0. When this guy responds back, it'll send a SYN of 1. It'll send a SYN of, it'll send an acknowledgement of 1 back. An acknowledgement of 2. It'll acknowledge this one back. This is called, in TCP world, called forward acknowledgement. Basically, the idea is this. If I'm sending you something marked with a number, like let's say a 1, this guy can acknowledge me back by asking for the number 2 back. You follow me? So I sent you the 1, rather than saying, okay, I got the 1, I'm cool. I forward acknowledge by saying, can you give me the 2 now? So I'm making an assumption, since you're asking for the 2, what am I making the assumption of? That you received the 1. Now, in a TCP three-way handshake, initially, we do this in a single deal. So when we start sending larger chunks of data, then we do it, the acknowledgement numbers grow fast. And this is why they're negotiating the window size. The window size is exactly how big of a chunk of data am I allowed to send to you. So the larger the chunk of data, the faster it acknowledges. So let's take a look at the stream as this happens so you hopefully can pick up on this. So what comes back? Notice that I'm acknowledging that last synchronization. So you got the sync acknowledge. Now, when you actually get the TCP flow happening here, notice that the sequence number grows. See, this is 480 now, right? So I'm basically saying, okay, here's my sequence number. I'm acknowledging the last thing you sent to me. And now you're going to start seeing the sequence numbers grow. So if you keep going down the list here, you'll see how that works. So here comes the response back. What is the acknowledgement number? 480. So it's acknowledging that last synchronization. And it keeps going that way. Now let's dive into then forward acknowledgement so you can see how that works. All right, here we go. So let's say TCP has a chunk of data actually, let me do this a little. We have some information we would like to send. With the TCP protocol. So I'm going to negotiate with another machine. I'm going to establish my window size. The window size is going to be the size in bytes that I can send at one given time. So for lack of a better purpose, let's say we set that it's 4K. So let's say I set my window size to 4K. Okay? And so the other side also is going to be set to 4K. 4,000 bytes. So the window size between the two machines must be identical. Now, the larger the window size, the faster the communication goes, right? Because I'm sending larger chunks. So I want you to understand why it's faster. If I've got a whole bunch of stuff to send, and I'm going to send only parts of it at a time, if I send this part, and I have to wait for an acknowledgement to come back, right? Then I can send this part, and I have to wait for an acknowledgement to come back. The smaller your window size, guess what you have to wait more for? You have to wait for more acknowledgments. So the window size, the larger the window size, the fewer acknowledgments you have to wait for. So therefore the communication is much faster. The smaller the window size, the slower the communication is because you're waiting for more acknowledgments, but the more reliable it is. Right? So the larger I send, the more chances there are of failure on them. Now, I'm always getting peppered by the neighborhood boys on how to make their first-person shooting gaming experience better. So one of the things that they caught on to was that they could manipulate the window size of their machine. So they figured out how they could go in the registry and jack the window size of the windows to be really large, thinking the larger the TCP window size, the faster my communication would go. But I had to spoil their fun because the window size is a negotiation between you and the server you're talking to. The server always wins, right? The client proposes a window size based on conditions. Windows doesn't care. It always says, I want this. And the server will say,
no, here is the window size that you're going to get. And then the client says, okay. So my little gamers thought they were fooling the system. He goes, I made my window size bigger and so much faster now. Window size is the same. Right? So it doesn't change, right? So you get the idea though. The faster window size, the faster communication. TCP machines naturally want to push the window size up higher because they want the communication to go faster, but at a point of diminishing returns, because there are failures if the wait longer for retry waits. Now, if I have a window size, let's say these are all conveniently 1 character big. They're not, but let's say they are. Then what happens is I'm going to take the window and I'm going to send a portion of my information. So maybe I have the I and FO ready to go out. I'm going to number these. And when I say number, guess how I'm numbering them? With acknowledgments and sequence numbers, like we're seeing in that communication stack right there. So these are now going to go out onto the network wire, right? 1, 2, 3, 4 are going to fly out there on the network wire. Follow me? Now they're going to arrive over here. Now if they all arrive, right, it doesn't matter in what order, they all arrive on a reassembly. Now what I'm going to do is I'm going to acknowledge and ask for the next sequence. So I'm going to get an acknowledgement back saying, can I get, I'm acknowledging the 5, forward acknowledgement. This guy will then slide the window, this is called a sliding window. I'll slide the window to the next group, ready to go out. You follow me? Now, we're not actually sending a word-like information. We're sending a chunk of data, right? I'm just using that to be fun. But you'll get the idea that it'll put it in there to the next one. So this is called flow control. Notice how I'm controlling the flow of the communication. By sending it only out in window chunks. Right? It's only going out in window chunks. I'm sequencing them with acknowledgement sequence numbers. Right? And I'm getting reliable communication. Now, here's how the reliability factor works. Let's say that I get 1, 3, and 4, but 2 never shows up. So 2 never shows. So what is this machine going to acknowledge back? It's going to ask for 3 back. It's going to acknowledge 3, right? What does that tell me? The 2 was never received, right? Oh, I'm sorry, no, I said that wrong. No, it's going to forward acknowledge 2, I'm sorry. It's going to forward acknowledge 2. That tells me that it got 1. Now, do I know if it got 3 and 4? No, I don't know. I only know that it got 2. I would only get that I got 1. So now, I'm not going to slide the window the entire distance. In fact, TCP is going to stop, and it's going to resend just 2. This is called one and wait. That's what TCP deploys, a one and wait strategy. Other protocols are different. So it's going to send 2 out. Now, what am I hoping that I'll get an acknowledgement back for? I'm hoping that I'll get an acknowledgement back for 5. You're right. I'm hoping that I'll get a 5 acknowledgement back. Because that meant I got 3 and 4, and my one and wait strategy paid off, right? I didn't have to resend 3 and 4 again. Now, what would really suck is if I sent the 2, and I get a 4 acknowledgement for a 3 back. Oh, I have to resend 3 again. Right? And then I get an acknowledgement for 4 back. I got to resend 4 again, right? So that in that case, my one and wait strategy didn't work, right? And then once I get the 4 back, now I can slide the window. You follow me? So this is what we call forward acknowledgement, and this is how error recovery occurs. Now these guys have timers set on them, so whenever they're set out, it start a timing process. So they never get a response. They can reset the whole stack. Or tell the application layer they're out of luck. Right? If TCP error recovery works, you never know that it works because the communication reliably got there. If TCP is unable to ever get an acknowledgement, you will get a timeout. Right? Okay, any questions about this? Let's call forward acknowledgement.
And they don't have to be arrived in the same order either.
So how would you change your Windows size if you didn't do that?
The server and the client have to cooperate in a window size negotiation.
Is there any way you can get them to cooperate, or they have to cooperate?
Well, the TCP protocol stack is usually designed to fluctuate the window size based on current conditions. It's kind of hard to say. But yeah, you could call up the guy that's running the server and say, hey, could you jack your TCP window size up to 128K? I'll do the same on mine. And then, you know, I don't know if there's a way to tweak the TCP stack where it won't change the window size regardless of the performance of the network. I don't know if you can do that. I haven't even looked at that. Okay, there you go. So this is forward acknowledgement. We already talked about that. Did that. Did that. All right. UDP doesn't establish. So with UDP, so over there to the left, I'm sending out all 6 datagrams. I send them, and I don't care if you get them in order or not. Right? In fact, have you ever been on a voice over IP call and somebody's voice starts cutting in and out or getting scrambled? That's because they sometimes don't arrive in the right order. And I don't care. I'm just going to send them out all real fast, right? And lost datagrams are sent. You never get your lost words back. They just disappear, right? So datagrams are never reset. So connectionless, unreliable.
Voice over IP is UDP. Is that why?
Voice over IP is UDP. DNS name server requests, when you go to get the IP address for your domain name, those DNS server requests are UDP. Anything that doesn't have to happen but needs to happen fast. Like my voice call doesn't have to happen. By the way, TCP and UDP both have the same port numbers and port number ranges. So I think, let me see if it's in Windows 7. It's been a while since I've looked in here. Let's look that up. There you go. Go to the following directory on your computer. Go to C, Windows, System32, Drivers, etc. If it'll even let you. You may get permission now. Is the C drive invisible to you? All right. You are going to log out or switch user, and you're going to log on as an administrator, and then you will be able to see it. So go to Start, Switch User, Control-Delete, and then you're going to type the name of your computer. To get the name of your computer, click on How do I log on to another domain. So teach970 / or your name of your computer, not teach970, whatever the name of your computer is, / Everybody uses the same account. NETWK. Network. NETWK. Network. Computer geeks have a sense of humor. It's a weird one. You just have to get used to it. Network. So type it. So click on how do I log on to another domain. Get your computer name, and then type the name of your computer / NETWK, and the password is going to be brute force, and the B and the F are capital. The B and the F are capital. Oops. So, Control-Delete, how to log on to another domain, get the name of your computer. So, mine is TH970, and I'm going to type / NETWK, and then I'm going to type my password, which is brute force with a capital B and a capital F. And now I'm in the computer. Oops. I killed my recording. All right, so now we've done that. Go to this directory. C, Windows, System32, drivers, etc. Your ETC. C, Windows, System32, drivers, etc. All right, when you get in there, double-click on the file that says protocol, and use Notepad to open it up. And you'll get a document that looks like this. So, a couple things I want you can see some common protocols and their port numbers. What I want you to understand here is TCP and UDP, TCP and UDP use port numbers from 0 to 65,535. And TCP port 53 is a different port than UDP port 53. Make sense? So two different ports. That you go from 0 to 65,535. Now, this website at iana.org has, I think, a more comprehensive list. Let's take a look. Yeah, this has a more comprehensive list at the IANA of all of the most common protocols. Okay? So you can take a look at that list. But UDP and TCP both have their own port number range. Okay, there you go. It's TCP and UDP for you. There's your port numbers. Everything that we do in network communications over the internet uses TCP or UDP, and they all use port numbers. So as a network administrator, one of your most common jobs is to deal with port numbers, allowing things through the firewall, understanding what port things are using, blah, 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 right? So everything you do, remote desktop connections require a different port number. Web traffic requires a port number. Secure shopping, SSL websites use a different port number. So in fact, most IT administrators are kind of as a job necessity required to memorize what protocols use with what ports. For example, you're in a meeting and somebody says, you know what, we need to allow that website through the firewall. And they tell you, and it uses SSL. So you immediately know in your mind, you know what, I need to allow TCP port 443. Right? Because you know A, HTTPS uses TCP, and B, it defaults to port 443. In fact, if you want to really sound smart, you would say, are you using the default port? Are you using the default port of 443? Well, yes, we are. Nice of you to ask. Well, that's okay. I'm a Genius Network Administrator. That's why I asked. Right? Does this make sense? So it's important to know. Now, some protocols use an exchange of two different port numbers. So, for example, look on this list for FTP. It's not in there. Why would it not have that in there? It's 21 and 22 is what it is, but it's not showing it in the list. You know what? That's a nice, fun document to look at, but it's probably better to look at another document. Common TCP port numbers. Oh, Wikipedia, what do you know? So yeah, I'll just have you memorize this whole list. I'm joking. I'm joking. Don't panic. All right, so here you go. Here's the official port. These show you all the official and unofficial ones. So here is port 20 and port 21. That's for FTP. Notice that FTP uses two port numbers. And so one of the port numbers is port 21, and one of the port numbers is port 20. Port 21 is used to establish the connection and the control of that connection. Port 20 is to transfer the data. So here's another intelligent conversation. Hey, we allowed us to be in the firewall. We can authenticate, but when we go to transfer the file, it doesn't work. Ah, you probably only allowed the control port 21 through. You also need to allow the transfer port of 20 through, right? So this is a common thing, is to understand what ports are used for what. So I want to allow DNS traffic through my firewall. What am I going to open? See if you can figure it out. I want to allow DNS client-server traffic through my firewall. What port am I going to open up? What protocol? I'm going to open up port 53 of what protocol? TCP and or UDP. Right? So most commonly it's UDP, but there are scenarios where DNS will use TCP. Right? So you can kind of see these, and these are important. They come up all the time. They're a constant part of our job, right? So the most I'll go through the most common ones real quick with you. So, for example, We never use quote of the day. It's an antiquated idea. But we use FTP all the time. We use SSH all the time. We use Telnet all the time. We use mail, simple mail. I mean, we use mail, right? Yeah, very, very common. So knowing how to knowing port 25 for mail is like, you have to know that, right? If you don't know that, you'll be laughed at. Okay, the time protocol. We talk about that one a lot. WINS, we do this one all the time. TACACS, an authentication protocol, we use that all the time. DNS, we use that all the time. UDP 67 for DHCP, that's very common. Trivial file transfer protocol, very common. Gopher, not so common. Finger, not so common. Port 80, you use that one on a daily basis, right? Let me find a couple others here that are big. Kerberos, port 88, that's very important for Windows Active Directory authentication. POP3, port 110, that's for retrieving mail off a mail server, very common as well. Nothing on that. NNTP, network time protocol, heavily used. These three ports right here are Microsoft heavy, 137 through 139. I'm always being asked if ports 137 through 139 are allowed through the firewall for older Windows machines. Okay? SQL, this is a big port. SNMP, another port commonly needed to allow. And that's getting pretty close. And you got a few others. HTTPS, port 443.
This was the only question, right?
Yeah. The rest are not as important. You can look them up when you need them. There's a lot in here that are starting to become more and more popular for different reasons, but those are the big ones. Cool. Now, up till port 1024, they're considered common. After 1024, all the way up to 65,000, they're not really common. So if you see somebody that's coming in on a port that's like 5,000 something, it's not a common registered protocol or port. Okay, there you go. So those are your TCP port numbers. Yes, go ahead.
There's like a whole bunch of them, like towards the top, or the beginning, that are all say unassigned. So does that mean like you may have like your own? If you had a protocol that wasn't on the common list, you could just assign it?
You're not allowed to, well, you can use one of those other ports if you want to, but if you want to try to register it and make it official, then you won't be able to use one of those port numbers. So what had happened when TCP was first created, it came out of the NCP days, which was a Xerox protocol, XCP or whatever, Xerox's protocols, where its roots were. Now, Xerox has this impression, and I think they still do, that they will eventually take over the entire world. That they will run the matrix and we'll all be machines, right? So that's their mentality, that we will all eventually be machines. So consequently, they wanted to make sure they built a protocol that could be future-proof. So they reserved a whole bunch of port numbers for one day, right? And that just kind of kept the same kind of mentality. It's kind of pervaded.
So those are all reserved by now?
It's actually now organized by the IANA. So the Internet Assignment Numbers Authority, IANA. So there's these agencies that have been given authority over the TCP/IP protocol stack, and IANA has been given the assignment by the Internet Engineering Task Force to assign out those numbers. So the IANA is that organization.
So what we want to change in that number official is get people knocking on your door.
Well, in order to make it official, you would have to put a request in with the IANA to make it official. And they would deny the request. It's not even worth it. Yeah, that port 0, I want to make it, the Guy Reams port. Because I'm writing this really cool app called the Guy Reams app, and I want everybody to use it. Now, they're probably going to say no. In fact, you'll notice that slowly but surely all the manufacturer-specific port numbers are being gutted out of that list because they're trying to make it as vendor agnostic as possible. But there is a registration process. So there are a variety of numbers in our lives that have to be registered. So one of them is TCP port numbers. Another one is IP addresses that are also controlled by the IANA. Another one is DNS names, which are also indirectly controlled by the IANA. There's a protocol called BGP, or Border Gateway Protocol. You have to create what we call an autonomous system number to get on the internet. That is also controlled by the IANA. Another one called SNMP, Simple Network Management Protocol, has an identifier, and you can get your own SNMP identifier. That has to be registered as well, publicly. And there's various others, like your MAC address, the physical address on your car. That has to be registered with the IEEE. So there's a variety of addresses in the computing science world that have to be registered for you to get. Did I answer your question? Now, there's nothing stopping you from going, port 5000, I kind of like that. I'm going to use that for my app. Nothing's stopping you from doing that. Your only problem is, well, let's say you thought, 3389. I was born in 1989, and I had twins and now 3, so I'm going to call my port 3389. That's my port. So my application, my really cool app, is going to be using port TCP 3389. Now that may all sound well and good to you, but your customer calls you up and goes, you know what? I'm already using port 3389 for Microsoft Remote Desktop. Could you change your port number? Or is there a way to change your port number? Because I really don't want to call Microsoft and ask them if they'll change theirs. Right? So you have to change the port number. If you ever do pick a port number to use, you should probably build a mechanism in your software to change it, so the customer can change it if they need to. Right? By the way, port 3389 is the Remote Desktop Protocol port number. Yeah, Microsoft Terminal Services, or RDP. So that is very common with Microsoft. Very good question, by the way. So that's TCP and UDP. Now, I'm probably going to stop here right now, getting wrapped up. I don't want to dive into the next subject because it's a detailed one. But I recommend that you go through the content. Where are you at in the Blackboard? I've lost my Blackboard site here. Hold on. So you should now be starting to move towards Unit 2. And that means you're going to be reading. There's an entire chapter on the transport layer in the Cisco curriculum. So you're going to start reading that. Got lots of activities for you to accomplish and a video for you to watch and some reading. So you can start diving right into that. So next week, we're going to dive into a much more detailed exercise involving the transport layer to try to help you really understand it. So we're going to be doing some some stuff with our machines to help you understand how to get the protocol stack to work. And I have a couple different ways I'm going to do that. So that's what we're going to be doing next week. It'll involve creating a web server and bringing a web server up and assigning port numbers. So you're going to be doing that next week. So go ahead and keep on top of your reading. Make sure you stay on top of the activities. And I'll see you next Wednesday.
Thanks for your help.
No problem.